Assalamualaikum and a very good morning. My name is Najah Wahida binti Kamaluddin and my matrix number is 198452.
My name is Arina binti Muhammad, number matric of 198783.
My name is Nur Farzana Atika binti Amal Zaini. My matric number is 196109.
My name is Afla binti Abdul Aziz and my matric number is 198148.
My name is Zulhelmi bin Fauzi and my matrix number is 197869.
My name is Farah Juwaria Atika binti Mazidik. My matric number is 195946.
And we are from group Van der Waals forces, more specific on hydrogen bond. And today we are going to present about what is the Van der Waals forces and what is the hydrogen bonds. Then we will discuss about what is the characteristics, properties, and also the example in applications of hydrogen bond and Van der Waals forces.
Van der Waals forces is general term used to define the attraction of intermolecular forces between molecules. Van der Waals interaction is the weakest of all intermolecular attraction between molecules. However, with a lot of Van der Waals forces interacting between two objects, the interaction can be very strong. There are three types of Van der Waals forces. First, we have dispersion forces. Second, we have dipole-dipole interaction. And third, we have hydrogen bonding. So, today I would like to tell you guys about hydrogen bonding. What is hydrogen bond? An attractive force called a hydrogen bond can exist between certain molecules. These bonds are weaker than ionic or covalent bonds because it takes less energy to break this type of bonds. However, a large number of these bonds going on can exert a strong phase. Hydrogen bonds are the results of an unequal charge distribution on a molecule. These molecules are said to be polar. If we look at a water molecule, we can see the oxygen atom shares electrons with two different hydrogen atoms. So in total, this molecule have 10 protons, 8 from oxygen and 1 each from the hydrogen atoms, and a total of 10 electrons, which are 2 shared between the oxygen atom and hydrogen atom number 1, while other 2 share between the oxygen atom and hydrogen atom number 2, and the other 6 non-share electrons from the oxygen atom. So this water molecule is electrically neutral.
So now I will just explain about the chemical bonding of the hydrogen bond. So water molecule is electrically neutral, but it has a partial positive side, which is the hydrogen side, and a partial negative side, which is the oxygen side of the molecule. The electrons are not shared equally within the molecule as they have a high probability of being found closer to the nucleus of the oxygen atom, giving that N a slightly negative charge. So, the hydrogen atoms end of the molecule will have a slightly positive charge. Those charge ends weakly attached to the positive end of the one molecule to the negative end of an adjacent water molecule. When water is in liquid form, there are a few hydrogen bonds. In a solid form, there are many hydrogen bonds. When water is in steam, there are no hydrogen bonds because the molecules are too far apart to form any bonds. So hydrogen bond only formed between hydrogen atoms that are covalently bonded to an oxygen or nitrogen or fluorine atom. Hydrogen bonds are also important in structure of protein. So hydrogen bond is an example of Van der Waals bonding. It is fair to say that Van der Waals forces are what holds the water in the liquid state.
There are 5 properties of hydrogen bond. First, odorless, colorless and tasteless. Second, toxicity. Third is viscosity and surface tension. Fourth is leakage and fifth is density. So I will tell the first properties of hydrogen, which is pureless, colorless and odorless. Pure hydrogen is odorless, colorless and tasteless, which makes it is undetectable to human eye and nose and most commonly found in water on earth. Second, it is because hydrogen is typically made up from the reaction between one atom of oxygen and 2 atoms of hydrogen to become a molecule, which is H2O, water. To add up, the oxygen also odorless and colorless unless the oxygen reacts with other substances that makes it change to odor or different from its initial properties. Hence, it makes the good reason why pure hydrogen is odorless. Second properties of hydrogen is toxicity. Hydrogen is non-toxic, but it can act as simple asphyxiant by displacing oxygen in air. Asphyxiation can cause first dizziness, second is nausea, third is vomiting, fourth is prostration, and fifth loss of consciousness. So, what is the relation between hydrogen and asphyxiation? As I stated from the previous point, hydrogen is made up from one atom of oxygen and two atoms of hydrogen. But when we submerge in the lower concentration of oxygen, hydrogen can replace the oxygen. Thus, it can lead to asphyxiation. Third property is viscosity and surface tension. Substances capable of forming hydrogen bonds tend to have higher viscosity than those that do not have hydrogen bonds. Generally, substances that have the possibility for multiple or many hydrogen bonding exhibit even higher viscosity. The substances which contain hydrogen bonding exist as an associated molecule, either intermolecular hydrogen bonding or intramolecular hydrogen bonding. Since their bonding are complicated, their flows comparatively difficult because of hydrogen bonding. Thus, they have higher viscosity and higher surface tension. The last properties of hydrogen is density. Density of gas is called vapor density, while the density of liquid is called liquid density. What is meant by vapor density and liquid density? Vapor density is the weight of a volume of pure vapor or gas compared to an equal volume of dry air at the same temperature and pressure, while liquid density means it is to measure how heavy the amount was measured. For hydrogen, it has lowest vapor density and lowest liquid density compared to methane and gasoline as shown. It is because hydrogen has lower atomic weight. Thus, as a conclusion, it has very lower density as a liquid or a gas.
Okay, so now I will explain to you about the characteristic of hydrogen bonding, which is one of the most important bond in the van der Waals group. So first of all, hydrogen bond is weaker than other normal ionic and covalent bond. This is because they are usually formed when an uneven charge distribution occurs. So it will create what we know as a dipole. So these dipoles can be produced by a random fluctuation of the electrons around what is normally an electrically symmetric field in the atom, or also known as when the electronegativity of the atom is the same. So next characteristic is hydrogen bonding is the strongest form compared to other dipole interaction. This is because hydrogen bonds are strong intermolecular forces which created when a hydrogen atom bonded to an electronegative atom approaches a nearby electronegative atom. So the greater electronegativity of the hydrogen bond acceptor will lead to an increase in hydrogen bond strength. So the third characteristic of hydrogen bonding is it only occurs in molecules. This is because hydrogen bonding is a special type of dipole-dipole attraction between molecules, not a covalent bond to a hydrogen atom. So it results from the attractive force between a hydrogen atom covalently bonded to a very electronegative atom such as nitrogen, oxygen, fluorine atom, and another very electronegative atom. And the next characteristic of hydrogen bonding is the melting and boiling point materials containing hydrogen bonding are abnormally high. This is because the high melting and boiling points of the compound containing hydrogen bonding is because extra energy needed to break the bonds.
So the first application is gecko feet. Gecko has the ability to stick and climb to the wall using the van der Waals forces. So actually the trick is to get enough area of the gecko foot and the wall close enough so that the van der Waals interaction will become effective. So gecko toes is actually padded with flexible ridges that are covered in tiny hair-like structure which much thinner than human hair that called setae. Each setae is covered in even tinier bristles which called spatulae. Spatulae help the geckos to stick to many surfaces using the principle of opposite charge attract. But these molecules have a side that is more positive and a side that is more negative. So when geckos walk on walls, they place their spatulae at such an angle that their positively or negatively charged sides get attracted to the opposite charge that present on the wall. Okay, so these forces of attraction is what we call van der Waals forces. Okay, so since gecko has billions of spatulae on its feet, hence they create enough van der Waals forces so that geckos can stick to the walls. Okay, next we move to the second application, which is application of hydrogen bond, that is water molecule. So hydrogen bonding occur most famously in between water molecules. So water molecule is actually made up of 2 hydrogen atom and 1 oxygen atom. So when one molecule of water attracts another, the two can bond together by the hydrogen bond, which adding more molecules result in more and more water sticking together. This hydrogen bond also is responsible for the crystal structure of ice, which allow ice to float on the water. Okay, next is DNA molecule. So human DNA is actually one of interesting example of hydrogen bond. In fact, that the hydrogen bond that occur between base pairs in a strand of DNA results in DNA's familiar double helix shape. This hydrogen bonds actually enables the replication of DNA strands.
That's all from us.
And we are from group
The Waals and hydrogen bonds.
Keep hygiene.
Stay safe